Myself, Renjida VR, currently pursuing MC at Marine College Kuttikanam Autonomous. Today, I am here to take the presentation about sum of subset problem using the backtracking approach. Without further delay, let us begin this presentation. Let us check what is backtracking. Backtracking is an algorithm technique. It tries to solve all possible choices and to solve a problem. It is a step-by-step method of solving a problem. At each step, it makes the choices and make forward. If a choice does not lead to a solution, it goes back and tries another solution. The process is called backtracking. Why we need backtracking? It helps to find multiple possible combinations and also check every valid options. Using this, we can understand more about this deadlock. Here is an example given. It is a starting node S. The S need to reach at the node G. So S start is traveling. The first S start went from S to A, then from A to B. From after reaching B, the S cannot go further. It is the last node. That is a dead node. So the S need to go back. In this case, the backtracking approach is happening here. From B, it has been gone back to the node A. From A, it checks where can be gone from A. It goes to the node C. From C, it is also a dead end. Dead end, so it cannot be go further. It need to be traverse back to the node A. From A, it again come back to the node comes back to the starting stage. From then it can again started its traveling from S to D, then from D to E. Then after reaching at the E, it sees that it is also the dead end. So it need to be backtracked to the node D. Then from D, it has to be traveled from F. From F, it need to be cannot be goes further. That is the last node. So we can be goes from F to G. When reaching at G, it has been reached at the end of the has satisfied the result that it has been reached at the node G. This is the method how the backtracking is working. Now let us check a real world scenario. Let us find all the subject combination that the total exactly says. That is actually we have four subjects, that is maths, physics, chemistry and English, and given a target sum that is 6. When taking the subset of this subset, we need to get this target sum. So there is a condition given that each subject must can be chosen only once. Using a backtracking algorithm, we need to find this example, real world example. Backtracking process. Start with an empty selection. Add one subject at a time. If the total is greater than 6, then we need to perform backtracking. If the total is equal to 6, then it is a valid solution. Using a real-world example, we can try to understand more about this backtracking. The weight of the subjects are given at here, that is English, Physics, Maths and Chemistry. These subjects weights are given at the right side and the targeted sum is also given, that is 6. We need at the initial stage we are considering the node as 0 and this can be divided into two parts, that is left side and right side. In the left side we are taking the sum, that is we are including this part, and on the right side we are excluding, that is we are separating this from that with the initial node. Here it is given in the left side, that is 0 plus 2, it is given as 2, and this 2 is taken as the weight of the first subject, that is 2, that we are adding this 2 to the initial node, that is 2 plus 0, that is equal to 2, and at the right hand side we are excluding, that is we are not including this 2 to this 0, so we are considering that as 0. Taking the other subject mark, that is 3. Now we are adding this 3 to the 3 at the left hand side and excluding 3 at the right hand side. Then that is 2 plus 3, that is equal to 5 at the newly created node, and we are excluding at the right hand side, that is 2 minus 0 is equal to 2. Then in the case of zeros, we are including 3, that is 0 plus 3 is equal to 3, and we are excluding, that is 0 minus 3, that we are not including this 0, so we are getting 0 there. Now we are taking the another subject, that is physics. Physics, its weight is 4. We are adding 4 at the left side and subtracting from the right side. That is adding from the 5, it is adding 4. That is 5 plus 4 is equal to 9. And here we have reached at the 9. Our targeted sum is 6. It is 9 is greater than 6. So we have to bound, or we need to prune this 9 from here. Next we need to exclude 4. That is, we have already 5, we are writing 5 there. Then in the case of 2, we are including 4, that is 2 plus 4 is equal to 6. And here we got the targeted sum 6. We have got one solution here. Then we are excluding 4 from here on the right hand side. So we are writing 2 as there, and we are including 4 at the right. In the case of 3, we are including 4 at the here for the 3, that is 4 plus 3 is equal to 7. That is 7 is greater than 6. So we are pruning, or we are bound. There is a bound function. Then at the right side, we are not including that. Including there, so we are writing 3 as such as. And also in the case of 0, we are including 3, that we are including 4, that is 0 plus 4 is equal to 4, and we are excluding, that is 0 we are getting. This is the case of and the subject. In this case we have got a solution, that is got a solution 6, that we have from 0 to, that is from 0 to 2, that is included. That is in the case of subject max, that is subject, that is 2. Then it has been excluded. This is excluded, then this is included. That is 3 is excluded and 4 is included. 4 is included, that is then 2 plus 4 is equal to 6. We have got the first solution, that is 2 for the max and 3 for the physics. That is we have got one solution here. Here we are taking the last subject, that is English. Its weight is 1. Then we are adding 1 to the existing one. Here we have the 9 is there. We have pruned it away, so we no need to consider this 9. Now coming to this 5, we need to add one the last subject mark, that is 1 to this, that is 5 plus 1, that is 6. We have got at the again one more targeted some satisfy one more output here. So that is here the value was the path was here it is included, it is excluded, then it is included. We need to find the sum, that is here we are here we have added 2, then here we have added 3, then here we have added 4, then here it is excluded, so we need to consider. So then here we need to add 1, that is 2 plus 3 plus 1 is equal to 6. Here we have got another output here. Then on the right hand side, it is not included, so we are writing as such as. Then on the here it is already we have got this output here. Then on the right hand side, it is we are not including this, so we are writing as such as. Then here in the case of 7, we already pruned there. In the case of 3, we are not including that. Then in the case of 4, then we are here is also no right hand side, it only left hand side, so we are excluding that. So we are writing that 4 as such as, it is 4 that as such as. Then in the case of 0 plus 1, then it is 1, then 0 plus 1, that is equal to 1. Then at the 0 we are including, so it is writing 0. So in here, through this we have got a 2 targeted some example, that is the nodes are this using this backtracking approaches, it lead to the targeted sum 6 in 2 cases. That is from the above example, we have seen that we have got the targeted sum 6 by including the path 2, excluded the path 3, then included the path 4, then excluded the path 4. That is when we are taking the sum of 2 and 4, then it will we got the targeted sum 6. That then also in another case, that is when we included the path 2, included 3, excluded 4, and included 1. Then when we taking the sum, that is 2 plus 3 plus 1, that is also 6, we have got a 2 targeted sum. These subjects were that max, 2 was max and 4 was physics. Not physics, it was chemistry, that is max and chemistry. And when we take the sum of max, physics and English, then we also get the targeted sum 6 there. Why in this scenario, that is data structure and the algorithm that is used here? In the study time planning problem, a student has many subjects and they must choose a right combination whose total study time is exactly 6. The trying all combination manually, it is difficult. The number of combinations increases as subject increases. So we must check all possible choices, not just one. So an algorithm that is needed, then tried each combination step by step. Stop when the total time becomes more than 6 and find all the correct solution. The data structure algorithm such as list and arrays that is needed. Then store the subjects names and hours. Then keep a track to select the subjects while checking the combination. The data structure used here is the arrays and the list. The two store study hours. The list that stores the selected subjects and the integers that store the current total hours. The algorithm step. Start with the no subject selected. Then choose one subject and did it study hour. Then check the total hours. If the total is equal to 6, then it is a valid study plan. If it is greater than 6, then it is stop and go back. Then remove the last subject and it tries another one. Then repeat until all the choices are checked. This is the algorithms used here. The time complexity can be seen here. The time complexity of 3 cases, that is worst case, average case, and the best case. The worst case, that is big of 2 raised to n, and each object can be either selected or not selected, and all possible combinations are checked there. And the average case, that is big of 2 raised to n, that is the most combinations still need to be explored. And the best case, that is order of 1, that is if valid combination is found, then immediately invalid combination is founded immediately. Then n is equal to subject. And the space complexity is that order of n, and that is used a regression stack and the list of selected subject. We can check the issues and the limitations that the algorithm may check many combinations, so it becomes slow when the number of subjects increases. Then the next one is the time complexity is exponential, so it is not suitable for a large inputs. So the best used for this is only for a small data set. Next, the real world challenges in the study time planning scenario. That is, the students must have many subjects, increasing the number of combinations. The study hours may change, so the plan may need to be recalculated. The real study planning may include priorities or deadlines, which is not considered here. Then we can check the algorithm. Algorithm is appropriate. The arrays or the list are the simple and easy store the subjects and hours. The DFS with the backtracking checks all the possible combination correctly. It stops early when the total hours exceeded targeted saving time and ensures no valid study planning is needed. Now it came to the conclusion that in the study planning problem, we used a simple data structure like arrays and lists to store the data, to store the subjects and their study hours. We applied a DFS with the backtracking to explore all possible subject combinations and find those that the total exactly 6 hours. This approach ensures that each subject is chosen only once and avoid unnecessary work by stopping when the total exceeded the targets. Although a method has limited for large input and it is easy to understand, accurate and effective for a small real world planning problem. Thank you.